For day 2, we're going to spend some time talking about the midpoint of a segment. By definition, a midpoint of a segment divides a segment into two congruent segments. So we've talked about midpoints before. There's a common sense idea that goes with them, but now I'm actually giving you the formal definition. So if you have a segment that goes from A to B, the midpoint of this segment will be the point that's right in the middle of them, between A and B. When that happens, the two parts of the segment on either side are equal to each other. So if this whole entire segment was 10 and you have a midpoint right here, that means that both of the two parts are going to be 5. In the questions that you see here, they say find the midpoint of the following segments. So I have a segment that goes from A to B. They're telling me the midpoint is C. So if I was to look at this, I could eyeball where the segment is, but if we want to really think about it, and I count how many spaces apart they are, I can see that they are 1, 2, 3, 4, 5, 6, 7, 8 spaces apart. So from either end, if I count 4, my point C is going to be right here. So my coordinates of C are 1, 2. They want to know the length of AC. Well, if the whole thing was 8, then from here to here is going to be 4, and from here to here is also going to be 4. Which means that my whole entire segment, like we said, is 8. In the next question, it's the same idea. Our segment, though, in this case is 3 units long, which means that when I place point C in the middle of that segment, it will be 1.5 units from each A and B. So point C is here. C has coordinates over 3, up 1, 2, 3.5. So 3, 3.5. The length from A to C, that's this section that's here, is half of 3, or 1.5. The segment from B to C is right here, also half of 3, or 1.5. When we take a look at question 3, we can eyeball the midpoint to be here. If you really wanted to, you could look at the slope of that segment, because if I was to do slope to go from A to C, I would go over 2 and up 1. As long as I can go over 2 and up 1 to get to B, that's guaranteeing me that point C is right in the middle. So point A has coordinates 1, 2. Point B had coordinates 1, 2, 3, 4, 5, 1, 2, 3, 5, 4. And point C has coordinates 3, 3. What you will notice is that the midpoint is exactly in between the x's of A and B and then the y's. So if I look at the x's from A and B, it's 1 and 5. Right in the middle of those is 3. And I look at the y's from A and B, 2 and 4, and right in the middle of those is 3. Technically, the midpoint is the average of its endpoints. When you take a look at the next page, it talks about the midpoint and our formula to find it, and you've seen this formula. We know that we're going to average together the x's and average together the y's. So in question 4, they're telling me that I have a midpoint that goes from C to D, and on the segment that goes from C to D, and I'm looking for the coordinates of M. I could put these points in here and say what's exactly in between 4 and 6 and get 5, what's exactly in between 1 and 5 and get 3, and calculate it that way. Or what usually is done, so for the midpoint M, if we use the formula, we take the x's and add them and divide by 2. And then we take the y's and add them and divide by 2. The first coordinate turns out to be 6 plus 4, which is 10 over 2. The second coordinate, or the y coordinate, 5 plus 1, which is 6 divided by 2, 5, 3. So when we plug in to the formula, we get the same thing that we would get if we applied some common sense to that question. In question 5, same question. I'm going to do it without a picture this time, because I know that I have a formula for midpoint that says I can add the x's together and divide by 2. I can add the y's together and divide by 2. When I evaluate the x, negative 2 plus 4 is 2, 2 divided by 2 is 1. Evaluate the y, 3 plus negative 3 is 0, 0 divided by 2 is 0, and those become the coordinates of my midpoint. Questions 6 and 7 have a little bit different idea on them. In question 6, they're telling us that we have a segment that goes from C to D, and C has coordinates 6, 5, and M, the midpoint, has coordinates 4, 1. That means the midpoint that you already know is given to you, the middle point. So if I look at what happens when I go from 6 to 4, I can see that what happened is I did a minus 2. So if I do another minus 2 to the 4, I get 2. If I look at the 5 and the 1, from 5 to 1, I minus 4. If I do 1 and minus another 4, I'll get negative 3. So I look at what happened between the first endpoint and the midpoint, and then I keep it consistent and do the same exact thing. If you were to put this on a piece of graph paper, here's where point C is. M is 4, 1. This is M, and I'm really looking for D, and when I did that, I got 2, negative 3. So here's point D, and you can see that that would be the midpoint of that segment that went through and connected them. Again, another thing that you can do is you can say from D left 2 up 4, from M left 2 up 4. If they're the same, then that means that point M has to be the midpoint. The question 7, the second question, they're telling me that I have a segment that goes from A to B. Again, I have a midpoint that I know the coordinates of. It's negative 2, 3. B is 1, 4. I want to look at what happened when I moved from the X to the X. So from here to here, it was minus 3. So I have to start at negative 2 and minus another 3, which gives me negative 5. When I look at the X's, 4 minus 1 gives me 3. 3 minus 1 gives me 2, and that becomes my coordinates of the other endpoint. Taking a look at this on the graph, point A is negative 2, 3. Point B is 1, 4. Here's M. Here's B. Point A, negative 5, 2 is here. Is it appropriate to have M be the midpoint of the segment that goes from A to B? Yes, it is. You could say I went left 3 up 1, left 3 up 1 to verify that M really is the midpoint. That would end up working. So sometimes they give you the end point and the midpoint. You have to find out what's happening at the other end. You can calculate like we did here by seeing what happened and being consistent, or you can put it on your graph. In the next section, they're talking about B being the midpoint of the segment that goes from A to C. So I have a segment that goes from A to C, and B is the midpoint of it. If that is the case, then what I know is that AB, the first part, is congruent to the second part. And I also know that AB, the measure of it, will be half of AC, and that BC is half of AC. So we can do half measurements. So for question number 8, they're telling us, same picture, that AB is 15. They want to know how big the whole thing is. If one part's 15, so is the other. 15 plus 15 gives me 30 for the whole entire segment. In question 9, we have the same picture. We have AC. B is here. The whole thing, AC, is told to be 28. Because B is the midpoint, those two parts have to be equal. So to find BC, I'm essentially taking 28 and dividing by 2 and finding out that the one part is 14. AB would be 14 as well. Question 10, same idea, except in question 10 they put the algebra in there. We learn a concept, we work with numbers, and then of course we put some algebra in there. So here's my same picture. So in this case, 5x plus 2 goes here. BC is 4x plus 6. They're asking me to find this length that's right here. They want to know how big AB is. In this particular question, please remember that because these two parts are equal, I can set 5x plus 2 equal to 4x plus 6. When I go through and solve, I get that x is 4. They didn't want x though, they wanted AB. So I'm going to do 5 times 4 plus 2, which is going to give me a final answer of 22. In question 11, same picture. All of these questions use the same exact picture. I have that AC, the whole thing, is x squared minus 18. AB is x plus 3. And they ask me to find how big BC is. What we need to remember here is you can't put an X on BC because that's what you're looking for. BC is the same size as AB because B is the midpoint, which means if the left-hand side is x plus 3, so's the right. So I theoretically know that the whole thing, x squared minus 18, is equal to 2x plus 3's. X plus 3 plus x plus 3. So x squared minus 18 equals 2x plus 6. It's a quadratic equation, so I want to get it equal to 0. I'm going to factor, so x minus 6 and x plus 4. And then when I make my little t-chart and solve, I end up getting that x is 6 or x is equal to negative 4. In this particular case, we don't reject the negative 4 simply because it's negative. We take the negative 4 and we substitute it in. If I was to substitute it in right here, it would be fine. But if I put the negative 4 in here, I would get negative 1, and that can't happen, so that's the rejected answer. X equals 6 is my final, not final answer, is my answer for x. My final answer is that BC is equal to x plus 3, which is 6 plus 3, which ends up equaling 9. So my final answer is that BC is equal to 9. One last section that we need to talk about today is how to construct a midpoint. Basically, it is the same thing as doing the construction for a perpendicular bisector, which you already know. So if you flip to the next page, we have a couple of directions, a couple of problems with the directions that say construct the midpoint of each segment and label it M. I'm going to do the same thing that I do for a perpendicular bisector. I'm going to take my compass, I'm going to move it over so that it has its point on the point of, I think I'm going to do that. I don't know. I'm having a hard time here. Let's do this. So I'm going to move it over so that the point of the compass is on one end point. I am going to open my compass. I'm going to do it upside down because I'm kind of running out of room up there at the top. So I'm going to put my compass like this. I'm going to move my compass so that the pencil, pen, whatever you have in there, is lined up with the other point. And I am going to make an arc. And then I'm going to take my compass. I'm going to move the compass point over here now. Make the same size arc. And when I do that, I can now take my ruler, line it up with the point at the top, which of course we can't see on mine because it kind of went off the page. Just humor me, pretend you can see it. I'm going to do that. Line it up, draw in that line. that connects the upper X and the lower X. And when I do that, I have essentially created a perpendicular bisector. In this case, we're not so concerned about the perpendicular part, we're concerned about finding the midpoint. So that perpendicular bisector is identifying the midpoint for you. In question 13, it's the same thing. In question 13, I'm going to put my compass at one end point. Make sure that I have it lined right up with that one point. It really only needs to be past the halfway point. That's kind of the way that we've done things right along, is past the halfway point. But if by chance you happen to, by chance you happen to reorganize that, which you might, now I can make my compass over here, and then go back, pick up my ruler, and I can draw that in. So when I draw this in here, it takes a little bit for me to get my ruler lined up just so. I can draw that in. And this point that's right here, that sits on the perpendicular bisector, also creates the midpoint for me. So on a scale of 1 to 5, this is one of those very, very zero scale constructions that we're doing. It should be something that you think is pretty easy.